Hello, everyone, and welcome to today's webinar presentation, The Benefits of Open Source and the Risks of Open Core, brought to you by Instaclustr. I would like to introduce you to our presenter. Our presenter today is Ben Bromhead, CTO and co-founder of Instaclustr. As Chief Technology Officer and co-founder at Instaclustr, Ben sets the technical direction for the company. Prior to Instaclustr, Ben worked as an independent consultant developing NoSQL solutions for enterprises and was running a high-tech cryptographic and cybersecurity formal testing laboratory at BAE Systems and StratSec. All right, now, without further ado, Ben, you can take it away.
Hey, thanks so much for that, and good morning or good afternoon to everyone who has joined us here today. We've got a nice juicy topic for you, and we'll kind of be digging into a little bit around open source and some of the different business models around that, and kind of what that means for you as someone who might be adopting or picking up a piece of open source technology and bringing it into your stack, right? And using it to solve a particular challenge that you might have in front of you. So what we'll do is, of course, try and define open source. This can be a little bit of a curly or a squishy idea to try and define. However, I think it's certainly worth at least giving it a good go and trying to draw a box around it, right? So, really, it boils down to a few different things, right? And open source really provides a number of different qualities or attributes that make it so powerful, right? And the first one that I really want to kind of name check, we'll talk about is it tends to be very much based around communities, right? So it is a community usually made up of programmers or software developers, however you want to kind of call that, end users, right? So the people that work on the software, the project, and the people that use the project. And quite often they can be one and the same, right? So certainly people that actively use a given project, will quite often be the same people that are contributing towards that, right? And that community will be quite often global in its span, or at least quite geographically diverse. And it's focused really around collaboration to improve the project, right? And the way that works is it can be very much centered around improving the code, right? So the artifacts that go into producing the binary. It can also be very much focused around improving, say, documentation. It can be involved in answering other users' questions. There's obviously many different ways that people are part of those communities, but it is very much a community in the sense of a set of shared goals, a set of shared identity, and that's one of kind of the core things of open source. It, of course, also is very dependent on the license that is provided, or that the code and the documentation and other artifacts is provided to that broader community, right? And that tends to be one of the main things that people go to when they talk about open source software, is the license, right? And there are a number of different open source licenses out there that all kind of provide different flavors, but fundamentally they provide a set of rights, right? And those rights usually center around the right to use, the right to change, and then the right to share that software, right? As part of that as well, and as part of that, I guess the interaction between the license and the community, you quite often see that those communities form around the project, around transparent communications. So all decisions are generally made in the open about a given open source project, and tend to be kind of fully documented and searchable around that. And that review around those decisions, whether it's merging a patch all the way up to technical direction or community direction, generally have a pretty public and inclusive review process as well, right? And so what you end up with is a model that really allows everyone to use the software, and really adapt it to their needs and share it with the broader community, right? So um, you know, what's really interesting is that these simple practices, they kind of fundamentally revolutionized, the software industry, and certainly kind of changed it, for the better, right? If you think about, the very, very early days of the software industry, where people were working on, say, Unix, they were doing it in a very collaborative method, in universities, and people just simply share source code. You had a situation where then AT&T turned around and started suing people, and that really then started to kind of codify the approach of open source and licenses, where people thought, hey, we really got to formalize this, right? And since that point and since that time, obviously there was a little bit of a slow burn as a lot of the software industry switched towards more of a proprietary approach after that. But then we really started to see a boom in open source software with the rise of Linux, and then a lot of other kind of projects that kind of centered around those philosophies, and we'll kind of jump into some of those a little bit later. So some of the key components we've obviously talked a little bit about, but just to kind of reiterate, it really centers around that community, the right to use and change and share software, the fact that we have a living repository, which is very much, provides a context, all the project history, how people have reviewed things, and then, of course, it's free to use and to operate there. So why did this kind of approach become so popular, right? And it's actually a really good question, because on the surface level, one, having a community around a bit of software with a certain set of rights doesn't immediately, I guess, make itself evident or obvious why we have this proliferation of open source software, and why that particular distribution model has become so popular, right? And I think what we got to acknowledge is that users and companies are starting to acknowledge the negative impact of using proprietary software, of using code and products that they don't necessarily have control over, right? And so in terms of what we certainly see as the popularity, and why we see people increasingly adopting open source technology, is I think, and we've got a couple of really great points here, but I think number one on the list is probably actually got to be developer velocity, right? And really what that means is, if you're an engineer and you're sitting there and you're like, hey, I've got to solve a particular problem, right? So whether that might be you're a web front end developer, right? And you've got to, I don't know, center a CSS div, or whether you are working on a back end, and you've got to achieve some particular task, and you're reaching for a software library that, say, might make doing Bloom filters a little bit easier, right, which is a probabilistic data structure. Or it might be that you're looking to kind of store information, and you're looking at different database choices, right? So there's a whole spectrum of open source software, but at the end of the day, open source software makes it so much faster to get up and running, right? You as an engineer, you can just reach for that particular tool, you can download it, you can have a look at the source code, you can have a look at the community or the documentation. None of it's gated, none of it's paywall, none of it's hidden behind kind of a free trial sign up. You can just kind of either import that into your project, you can download it, whatever you're doing, and you've started to solve that particular problem, right? So, that certainly contributes to, I think, its main popularity. A little bit of what they call the virality of open source is just, how quickly it makes it easy to kind of solve the problem that you have right in front of you, right? You know, the other parts or the advantages tend to come a little bit later on in the path of adopting a particular open source project, right? Excuse me, I'm just having a wee sip of coffee there. The other components really come down to, you know, the benefits further on in your project lifecycle, right? So whether that's about avoiding lock-in, and what I mean by lock-in here is vendor lock-in, and you know, the ability to choose where you run a bit of software, who runs it for you, whether it's yourself or someone else, and where you kind of run that, right? It also means that you have the ability, you know, to I guess scale your usage of that. And I don't just mean that purely in the sense of a technical direction, right? You know, look, there's certainly plenty of open source software technologies out there that, you know, they just run on a single server and don't scale out in any particular way. But what it does mean is it's far easier to scale, you know, the staff available, you know, that you have potentially to hire for that piece of technology, right? Because it's so easy to use, because it tends to be a little bit more widely available, and because people can get familiar with software, not necessarily just in a pure commercial setting as well. They could be a hobbyist, they could be working on it as a passion project, they could just simply be interested in it. You know, you tend to find that you have much better scalability when it comes to, you know, finding people that are familiar with that particular piece of technology. You of course have access to active communities, so there's people that are very familiar with the piece of software that can help you answer questions, you know, have documentation, for example, or, you know, potentially even build other projects on top of that, right? So, you know, you might, for example, identify a particular database as the right way to use it, as a particular database is the right solution for what you're trying to do. But then people might have even, you know, kind of solved another proportion of your particular problem by, say, you know, having an API layer on top of that, right? Or building a backend as a service on top of that particular database, which, you know, might solve a number of your challenges as well, right? So it tends to be quite powerful because other people can reuse that project and, you know, further solve other challenges around that, right? You also have the compatibility side of things as well. It's really fascinating to see a particular example, say, of Postgres, right? Postgres is an awesome open source database. But what's really interesting with Postgres is you look at its API and protocol definition. It's open, of course. It has a well-known implemented open source, I guess, reference architecture, for lack of a better term. And you actually see a number of other open source projects, but also proprietary projects implement the Postgres API and protocol spec to be compatible with a wide range of drivers, right? So, you know, really interesting in how it kind of drives compatibility from that perspective, right? You know, a few other components as well that makes it a little bit easier. You know, you do have a lot of freedom from licensing tangles, right? So if you compare that to, say, either source available licenses or proprietary licenses, if you're looking to distribute your piece of software with either embedded capabilities from a project or a database or whatever it is, it always becomes a lot more complicated, or even a lot more expensive if you're doing that, just say, with, you know, a proprietary alternative, right? Whereas if it's an open source piece of software, as long as you meet the terms of the license, which are usually either attribution or recognition, or, you know, maybe a lookalike licensing kind of setup, you know, it kind of makes your life a lot easier when it comes to distribution there, right? Cool. So we've spent a lot of time talking about open source software and why it's so awesome, and, you know, what are kind of the benefits that people tend to get from it. And I think it's very much worth defining what is open core software, right? So This is kind of a term that's a little bit more recent and has really kind of sprung up to describe a particular, I guess, business model or approach to monetizing or commercializing an open source project, right? So what is an open core piece of software or project or distribution? Well, one, it's one that contains proprietary code mixed with open source code, right? And it tends to give you access to a community of developers who are associated with that project, but it also contains proprietary features that are released separately, right? And so quite often people will use an open core distribution or a open core offering, you know, for a few reasons. One is it tends to be commercially supported, right? So whoever wrote the proprietary bits that are sprinkled in there will support the whole package. And so people looking to adopt open source software where they don't necessarily have the in-house capability, or they might have a commercial requirement or an organizational requirement to have it commercially supported, you know, they will then look to a vendor that has an open core offering. Quite often in a particular project or community, that might just be the only option. You might also look at it from a convenience perspective. You know, certainly a lot of these companies will provide more convenient packaging or distribution capabilities. You know, so for example, the open source community might only provide you know, say a single binary distribution, whereas the vendor might provide, say, you know, Docker images and you know, packages, say for Debian or Red Hat or whatever that might be, right? So it tends to be a little bit more commercially convenient sometimes. And then the other part would be, you know, they certainly identify that some of those proprietary features might be useful, right? And so that'll lead them to kind of adopt it. You know, there were certainly risks associated with adopting open core software, right? And you know, we'll kind of talk a little bit later on in the slides around directly comparing you know, open source versus open core, but I think it's certainly worthwhile calling out some of the risks that are associated with this, right? So first, you know, customers who move up to, say, an enterprise edition or an open core version, they lose a lot of the benefits of open source, right? So as soon as you adopt that and as soon as you start using some of those proprietary features, you know, you've kind of signed yourself up to, you know, being attached to that particular vendor, right? So you're already kind of in the world of vendor lock-in. You also tend to, I guess, lose your ability or right to determine the project's roadmap when it comes to those proprietary features. You know, certainly, you know, you'll still be able to kind of contribute to the main project for the other bits and pieces, but you'll also be working off two separate code bases, right? Even though they might be similar in some regards. You know, the other thing is that we tend to see that the open core company usually feels that they need to maintain control over the core in order to ensure that it supports its enterprise edition, right? So what that kind of ends up playing out is a bit of an odd dynamic in the open source project itself, right? So you tend to see developers who contribute, you know, good features and, you know, to that project. If those features are directly competitive with some of those open core features, or you know, kind of encroach on some of the what that open core company see as their core competencies, you tend to see, particularly if the open core company has control over the open source project, a lot of those features tend to get rejected or kind of wither on the vine. And it means that contributors and otherwise, you know, very happy community members end up leaving the project in frustration, right? And so you see this dynamic really starting to poison the well a little bit of some of these projects if that open core company has kind of more total control or don't kind of get that balance right. And look, there are certainly some open core companies that do strike a bit of a better balance than others, but at the end of the day, it comes down to what incentives they're working with, right? I guess the other thing is that you got to think about what if a robust community does kind of develop despite of some of those challenges. The benefits that led to the dominance of open source really comes to play, right? And quite often the community can surpass the company's offerings, and tend to make that kind of obsolete. What we kind of see in practice is that those open core companies will usually release features a little bit earlier than the community version will, but inevitably we always see the community kind of catch up if it is a useful feature, right? The other thing as well is that people in the community can often underestimate the risks that they are adopting with going towards an open source project that does have an open core vendor around it, particularly one that owns the project, right? We've certainly seen in the past communities where licenses have been changed. So people who've made code contributions have seen the code that they've contributed, the license changed kind of underneath them, right? So it's a real kind of change of the good faith that a community's been built around. You certainly have seen that in, say, for example, the Elastic community as well, right? Which can be a bit of a challenge for those that are working on that particular project. So we'll just very quickly as well distinguish open core from some other trends that we see in the open source community, right? And I think it's kind of worth calling some of these out. Some of these kind of more directly related, but others are kind of how different companies have taken different approaches to commercializing open source, right? So I think some of the other trends that are worth talking about, so Red Hat, that tends to be one of the most often talked about or most successful, I guess, references that people talk about when you talk about commercial open source success, right? Now, what's really interesting is, Red Hat has been pretty much for most of the part of things, pretty pure play open source, right? So their approach has been very much, providing convenience and integration of a lot of their open source components, particularly through Red Hat Enterprise Linux. And when you run Red Hat Enterprise Linux, you are running a distribution of GNU Linux, right? So it means that you are adopting pure open source, but really what you're doing is you're paying Red Hat to maintain not only the operating system, but also the ecosystem, the packages around that, many of the compiler and hardware interactions, external dependencies, and customers have been very willing to pay Red Hat to maintain Linux on their behalf, right? I think what's really interesting is that their approach to it has been very successful. They don't extend projects with proprietary software. It isn't open core. It's been very much a very strong development approach where they've worked and supported and built a lot of this stuff, and made it very easy for their customers to kind of adopt, right? It's always interesting to think, will we ever see another Red Hat following that exact same business model in our lifetime? I think certainly Canonical, the folk that do Ubuntu, was certainly kind of following that path for a while, but I think they've kind of definitely diverged a little bit in kind of the markets that they're chasing. But this is just rampant speculation on my behalf. But it's also certainly very interesting to see Red Hat as a model of a company that's more or less stayed pretty true to that open source mantra, and has been very commercially successful off the back of that, right? The other big one that you would kind of argue has become commercially successful is MySQL. It's kind of the critical M in the historic LAMP stack. And before it was taken over by Oracle as part of their larger acquisition of Sun Microsystems, it had a bit of a complex strategy, but one that I would kind of argue kind of fit very well within that open source mantra, right? And so the way that they obviously made their money was that you could buy support and services from them. But MySQL, certainly they encourage customers to actually pay for individual features, right? If you wanted MySQL to do something that it didn't, um, MySQL AB would develop those features for you, and they sometimes would kind of provide that to their customers a little bit earlier than they would release it into the broader community. But every feature was very quickly incorporated into the open source version. The BSL license created by the founders of MySQL formalizes that delay in the release of software as open source, right? So you tend to have a proprietary feature that will eventually, over a period of months or even a longer time frame, depending on how you set up that BSL, eventually revert to an open source license, right? So you could argue that there is some degree of an open source approach to it, but it did certainly mean that their incentives were a lot closer aligned to the community, and that all features would certainly very quickly make their way into the open source version. MySQL, they also employed what's called a dual licensing approach. So if you ran your database as a separate program, you could use that just using the BSL. But if you wanted to embed that database into a proprietary offering, you needed to license that, right? So again, it doesn't super meet the criteria for an open source license because it is a restriction of use. But it certainly was closer aligned than, say, some of the other open core licenses that we've seen. MySQL has certainly become what I would say a very true open core offering since the Oracle purchase. However, there's still certainly a strong open source offering kind of forked from MySQL, which is MariaDB, right? And that kind of came off Monty Wadenius forking that. Monty he was one of the creators of MySQL, and they've got that as the open source alternative, and even Oracle and MariaDB certainly cooperate on sharing open source code, which is good to see, right? Some of the other trends that we tend to see, one is, we see a lot of open source communities and projects, they depend on funding from large institutions, right? The source of that funding and where people, get their paycheck to contribute on some of these projects, we're pretty firmly in the belief that that doesn't diminish from its open source status, right? As long as that we hold that license and the community kind of builds around that in the right way, corporate funding can be quite advantageous to open source projects, right? And this has been happening since time immemorial, whether it's directly funding people just to work on it, or it's funding for a particular feature. We see that very much as being part of kind of that open source ethos, right? The other trend that we also see is what's called closed core, right? And this is a very popular practice where a company contributes to an open source project that is not central to its business, right? So it is, they're not really taking any of those internal learnings or a production ready system or anything like that, at least not initially. And then open sourcing that or contributing to it, right? And a great example of this is, what we see a lot of major cloud-based companies, do. And Kubernetes is a great example of that, right? Kubernetes, was very much built as a lookalike for some internal Google systems, and open sourced and developed in around a community around that. But the learnings and the lessons hopefully kind of came through, but it wasn't certainly Google taking Borg or whatever the next iteration of Borg was, that gave rise to Kubernetes and open sourcing that. I think it sounds a little bit like splitting hairs over implementation or intention, but I think it's also just worth paying attention to that particular practice and understanding why certain communities form and kind of the genesis behind some of those, right? Some of the other ones that we've mentioned, I won't talk too much about dual licensing. We kind of touched on that with the MySQL example. And that's where the same software can be licensed in different ways as defined by the person who owns the IP. Some of the other trends we also see is inner source. So that's where the code base will stay either proprietary or just purely internal to a company. It might be an internal project, but it's an organizational practice where people can contribute and work on that piece of software in a very open source style manner, right? So anyone from the company can submit a pull request, and internal communities kind of form around that, right? The other one would be, and the other trend, and definitely we are seeing this more and more, which is called source available, right? And that's where a proprietary company offers their source code to customers, but it won't be under an open source license, right? And very recent, this has been happening for some time. One would argue that since the times of Unix, for example, that has certainly been source available. However, it certainly wasn't done under an open source license. And more recently, we see this with new licenses arising from database vendors, whether that's Mongo or Elastic, who have created the SSPL and the Elastic licenses, which look and smell very similar to open source licenses, but they tend to have restrictions on use, right? And so there we've got a number of examples where you can see the source code, you can have a look at it, you can even potentially submit contributions, but it doesn't fall under that open source license, right? So with all that kind of in mind, the different trends that we've seen in open source software, how different companies have commercialized it, some of the benefits of open source, some of the risks associated with open core vendors, and even some of the benefits that you might find with some of those open core vendors, really it comes down to, one versus the other, how you adopt open source software, right? And we tend to very much believe that open source software is better than an open core offering, right? One, it mitigates vendor lock-in, right, which is one of those core principles of freedom. It actually lends itself to a much healthier community, which, from the long-term success of the project, the long-term success of your use of that project in your own endeavors, it tends to be a much better thing when you have a healthier community that can, has an engaged set of developers. They can respond to patches, they can respond to bugs easier and security patches, and tend to produce a better set of features. The other thing as well that we also see quite commonly in open source software is, the increase in code quality, right? And code quality is, is quite a subjective kind of thing. But what we tend to see is that, certainly bugs in open source software tend to get fixed and released to their users far quicker than what happens in a proprietary piece of software, right? If you're looking at, say a patch within, say, a proprietary operating system, that can be months, whereas, you can talk about a matter of days when it comes to open source implementations, right? And, the other great thing about open source implementations is if there is a patch or a fix for a particular issue that you're facing, and even if that community hasn't, say, made a formal release or released a new set of binaries or packages, you're always able to grab that patch and I guess build or compile your own hotfix version and run that in production while you wait for that formal release as well, right? So the moment that piece of code or bug patch or whatever that might be, solving a particular challenge, that's always available to you a lot sooner than it might be in a proprietary setting. There's also a lot more eyes that tend to be on the source code as well. You've also got the chance to review it. Now, that's not to say that open source software has, less bugs or less security issues. Software is software, and there'll always kind of be bugs. But it really comes down to, the velocity or the speed in which those get resolved and identified. We tend to see open source really having a bit of a lead in that respect. So when you think about adopting a bit of software, right, it really comes down to a number of questions that you need to either ask yourself, right, or ask a vendor, right? So if you're engaging with a vendor, these are definitely things you want to think about. These are things that you want to keep in the back of your minds, and some of these you can kind of answer yourself, and others, you'll need to ask a vendor if you are working with a vendor, right? So the first one to check is the source code licensed correctly, right? So is it a unmodified OSI approved license? And so the OSI is the open source, sorry, one second, the open source initiative, and they've spent a lot of time working with open source licenses, helping to define it, helping to promote it. You can actually, go have a look at those at opensource.org. The second question that you really need to focus on and think about asking yourself or asking the vendor that you're working with is what the health of the community is like around the project, right? So it's not just about the code, even though we've said code here. It's very much around the health of the documentation, the health of the community around that particular project. What's the diversity like? And not just from the diversity of the individuals, but it's also the diversity of the organizations and who runs it, where do they run it, as well. Both are equally kind of important there. Is the project managed by an independent body, right? This is really, really important, right? It could be, the difference between control over a project, and a great example of this is projects that are underneath a open source foundation, right? Whether that might be the Linux Foundation, whether that might be the Apache Software Foundation. Having the project and the IP owned and managed by an independent body can make a huge difference to the health of that community. And then when you're working with a vendor, how does that vendor make money, right? Are they making it from selling you licenses for proprietary features, or are they making it from just supporting you, or are they making it from, say, offering that open source project as an online service, right? And then, of course, is there a roadmap for the project, right? So do you have certainty? Do you understand the direction the project's heading? Different open source communities will have different levels of formality around their roadmap. Certainly for some communities, it can be a list of issues in their GitHub or their Jira or their bug tracking, all the way down to a more formally defined and agreed upon roadmap within the community. But it's always certainly worth thinking about the direction that a project is heading in the future. And so certainly asking these questions and going through them and getting a great understanding will help you work out if you are working with kind of a true open source offering, and then also, get a better understanding of the health and of the communities around that, and really what you can start to expect when you do adopt this particular project. So let's take a little bit of a look at the state of, companies that devote themselves to open source and how they achieve sustainability, right? And, when we talk about sustainability in companies, it tends to be how do they make money and how do they, work within the communities while they're making, that revenue. So, as we've discussed, there's a number of different company models for open source software. of how companies can kind of commercialize around that. We've talked a lot about open core and closed core, right? So that'll be companies that very much, they're looking to, you pay for a license and you get the right to use software that that company has written and owned, right? So very, very typical distribution model. You've also got cloud offerings, right? And full disclosure, Instaclustr, my company, which we're now part of NetApp, we have a number of cloud offerings. That's how we commercialize a number of the open source projects that we work with, including Cassandra, Kafka, Postgres, Redis, and Elasticsearch. We all kind of offer those as managed databases on the public cloud. And so by us taking care of those and running those for you, we're really kind of commercializing that, and we're charging money for the care and feeding and the operations of that. And there's a number of companies that are doing this, right? It's obviously not just us. And they'll take the responsibility of running these for you, so you can obviously get on with the business of developing code against it. Now, this business model tends to only work with certain types of projects, right? Whether that is, and they tend to be much more focused towards, say, databases, right? Because they lend themselves to being run and offered as a standalone network service, right? You don't obviously tend to see this if it's just an open source, say, developers library, right? The other one, business model that tends to crop up a lot is a services or custom development model, right? And so that's where a company will offer feature development work or consulting services or support services around a given project as well, right? So that allows people that are adopting a particular project to, I guess, outsource some of the work that they'll need to do internally to kind of be successful around that. And then, of course, the last one is, a non-profit working on a particular project, right? So that's where it's much more of a charitable or a non-profit endeavor, and they might fund that through donations from other entities or other funding methods, but you certainly see those organizations, really working on it from a mission perspective and, doing it not to necessarily make a commercial profit off it, but really looking to more broadly contribute to things that way. So they're very much the main models that we tend to see pop up around open source software. We tend to pretty strongly believe in 2, 3, and 4. We've decided to kind of commercialize it at Instaclustr through a cloud-based offering. You certainly do need to be careful about what you adopt from a cloud offering, because you can certainly think you're adopting a pure open source implementation of it, but whoever is the cloud vendor or the person running this, they might have written it or implemented proprietary capabilities within that, and so you end up having an implicit proprietary adoption or dependency on a proprietary feature. So you certainly got to be a little bit careful around the features that you get from that. It can be sometimes a little bit harder to determine exactly what you're getting from some of those cloud offerings, but there are also, on the flip side, definitely just pure play open source offerings from a number of vendors, not just including us, right? So just to kind of wrap a lot of this up, fundamentally, open source projects, they've proven themselves to be incredibly long lasting, both in value to the broader ecosystem, the cost benefits they provide, the flexibility, and the awesome communities that have grown up around that. I'd certainly just point to kind of the granddaddy of them all, which is Linux. That powers what 98% of kind of web backends and servers in the world nowadays. So I think it's a pretty clear win, and a pretty awesome example of kind of the power of an open source community can have. Open core tends to be a riskier alternative around open source adoption. And I think that there's a lot of long-term risk associated with that, right? And of course, this whole topic can be incredibly complicated, right? Which I think is why it's really important to fully understand the implications of the path that you go through, right? And I think, we've covered a lot of topics here today, and we've talked about, a wide array of different ways that you can work within an open source community and how vendors work. I think really, I want to take it back to, if there's only one thing you take away from this webinar today, it's to think about these 5 questions, right? When you're looking at an open source piece of software, right? If you can kind of ask yourself these questions or talk to your vendor about these particular questions, it means that you're going into whatever situation with your eyes wide open. You understand the pros and cons, and that's not to say that it's necessarily a terrible thing if you do have to go down an open core path, right? But you are having a better understanding of the risks associated with that, the pros and cons of different paths. But I think these 5 questions are definitely the main ones that you should come away with from this webinar with, right? So with that, I think we'll kind of wrap up the presentation or the webinar component of this today, and I'd definitely like to open up to some questions if anyone has any. Alrighty, so we've got a few here. All right, so the first question that we have received is, does a proprietary offering an open core mean the same thing? Really, really great question. So first of all, the similarities is that both of those will have components that are proprietary. And what I mean by proprietary is that you don't necessarily have a license or right to distribute that code or those binaries, right? So you're the only one that is able to do anything with that. A pure proprietary offering means that all the code, the entire binary distribution, you might not even get access to the code, you just have a single license that is quite restrictive in terms of how you use it, right? So that means that you're probably the only one that can use it. There might be some rights restrictions as well, whereas open core, there will be a component of that is open source license, and then there'll be other components that is under a proprietary license, right? So they're very, very similar, but just it comes down to I guess the percentage of what's open source versus what's not, right? The second question that we've received today is, how difficult is it to move from open core to open source? Another great question, and one that's going to be highly dependent on the I guess the technical details, right? So how you've implemented and adopted a given open core project. If you have a lot of dependency on some of the proprietary features, it's obviously going to be a bit more challenging, right? You're probably going to have to rework some things or rewrite it or look at different options. But if you've adopted, say, an open core offering, say mainly just for a support perspective, and you've mainly just used a lot of the capabilities that are available otherwise in the open source project, that's going to be a much easier proposition, right? But of course, it all comes down to technical implementation details. So it's kind of hard to talk about that from the more specific side of things. But really, it comes down to what parts of the software that you use, right? 3. I've been told that migrating from open core to open source is very expensive, so it's not worth considering. again, I think this goes back to the other question around, how difficult it is. I think difficulty is a proxy for how expensive things are. So if you've obviously spent a lot of time adopting some of those enterprise grade features or proprietary features, then yeah, it is going to be more expensive, right? You have either expensive from a time perspective, or looking at other solutions, or whether it's a re-architect or whatever that might be. So there might be times where it is simply cheaper to keep paying that license fee, as painful as that might be. However, what we see in practice is that most people will only use kind of 5 to 10% of those proprietary features in an open core offering, right? So in practice, it tends actually to be a much cheaper exercise than you would imagine, right? So it really comes down to doing an audit of how you use a given bit of software and actually figuring out what features you use, and that'll kind of give you your answer. So in practice, and again, talking at very high levels of generality here, it actually tends to be a lot less expensive than you would think, right? Another great question that's come through. Do you want to comment on the supply chain hacks and risk mitigations, risks or the mitigations maybe? This is a really awesome question. Certainly, I think most recently we've seen a whole bunch of NPM packages that have been compromised as well. This is not the first time that has happened in the NPM ecosystem. It is not the first time that has happened in other package or development ecosystems. I think certainly it comes down to the maturity of the open source project that you are working with, about their controls around credentials, who can approve patches going into the community, into the project, how that's kind of audited, where that comes from. There are definitely some communities that are much better at it and have much better controls around it than others. We tend to see a lot more of the supply chain hacks when it comes to software libraries, to be honest, right? Because what ends up happening is that individual software libraries tend to have a much smaller community around them, right? It might tend to often be just say 1 or 2 developers. You end up finding that a software package or software library that they've developed ends up being incredibly popular. We've seen that with some packages as well, where the developer might also intentionally introduce changes into that, whether it's a political protest or a statement. I know that something like that happened at the kickoff of the invasion of Ukraine by Russia. That certainly some software maintainers, as a form of protest, introduced some changes into the packages that were quite destructive to some of the people that were using it if they were in certain geographies. So not only is it a supply chain hack risk, but it's also the people that work on the code itself, right? It's certainly worth thinking about that. Now, it's stuff like that is actually not just limited to open source software, right? Certainly, private companies are susceptible to supply chain hacks. That has happened numerous times. Commercial companies are also susceptible to bad actors. There's certainly been proprietary software where backdoors have been slipped in unintentionally. I think the thing is with open source software is that we tend to, again, see these issues, one, being picked up a lot quicker, and tend to also be resolved a lot quicker, just because of the visibility, right? And you've got a community of people that are far more invested in the success of that, right? So for example, with the NPM hacks, GitHub responded to those, some of the NPM package owners responded to those, right? In terms of the malicious internal actor as well, we saw some of the other committers to that particular, or the contributors to that particular project look and move very quickly to provide an alternative around that. Yeah, so definitely something worth thinking about is that supply chain risk. But certainly something that you got to be, I guess, cognizant of or aware of, no matter kind of where you adopt it from. But, I always go back to the fact with open source that, this stuff's going to get picked up and fixed a lot quicker and a lot sooner than it would otherwise with proprietary software, right? I think the other thing as well you got to acknowledge is it comes down to incentives, right? A proprietary vendor will have an incentive to not disclose, right? And I think people are getting a lot better at responsible disclosure, but certainly in the past we've seen a lot of pressure on proprietary implementations to not disclose or to quietly trying to patch that, as to not damage reputation, right? Whereas open source communities tend to move a lot quicker to kind of get these things fixed. What else? I think we've got one more question. What are some companies that are offering open core? Well, there's lots out there. I won't go through and name all of them, but it's a very common practice. Whether it's in, say, a database space, certainly most commercializers in that area are certainly working on an open core basis, whether it's say Elastic or Confluent with Kafka, for example. They're all kind of open core vendors. I think the thing to look out for is as soon as you see something that's like they brand it as an enterprise edition, right? As soon as you see that, that's a pretty good flag that that's an open core offering. And it's an interesting approach. You tend to see a lot of these companies say, hey, you've got to adopt this because it's enterprise grade or enterprise ready. Which particularly in the database world is pretty funny because a lot of these databases, particularly the distributed systems, they're already what I'd call enterprise grade. And so I think really just kind of pay attention to the marketing from your vendor, right? And ask those 5 questions that I pointed out, and you'll start to get a good amount of certainty when it comes to those kind of things. Cool. So I think that just about wraps up all the questions that I've seen come in. I think unless any more kind of pop up in the last few seconds, we'll kind of wrap it up and leave it there. I'd like to thank DZone for kind of hosting us. I'd like to thank everyone for attending, and I hope you all have a wonderful rest of your day. Thanks so much for attending. Cheers.
And with that, DZone would like to thank Ben for an outstanding presentation. DZone would also like to thank Instaclustr for providing our audience with a great webinar. Lastly, thank you to everyone who attended today, and we hope that you learned something new that will help you in your developer career.